It was not really until the climax of the space race that the US gained the upper hand against the USSR in space exploration. When Neil Armstrong landed on the moon in 1969, America was finally regarded as the victor. Nonetheless, the USSR was ready to retaliate through the KGB and began a more unconventional campaign to make sure it wasn't going to be left behind. The Soviets enlisted hundreds of spies that successfully obtained both classified and public intelligence related to the American space program. Thanks to its clandestine efforts, the Soviet Union was able to steal the first US shuttle design during an operation that took place in the late 70s and early 80s. The Russians called their carbon copy space shuttle the Buran, or Blizzard. This is an intriguing tale of the competition between the Cold War's two great powers, filled with politics, paranoia, war, and what historians have called the first recorded case of online spying. The year was 1974. The Vietnam War was about to end. The US forces were ready to leave Indochina as the Viet Cong slowly took over the democratic South. In the Korean demilitarized zone, tensions rose as the US slowly began to lose influence over the region. Nonetheless, America was winning the Cold War on another front, better known as the space race. On par with its military expansion, the country rapidly was taking over space, and the USSR couldn't keep up. A state of paranoia loomed over the Kremlin. The constant fear of being bombed from the sky by secret US aircraft threatened Moscow's security. During the last months of 1974, a secret meeting took place in the Kremlin with the USSR's top-tier officials. Vladimir Smirnov, head of the Military Industrial Commission, or VPK, tasked with directing military projects and laying strategies for obtaining new technologies, briefed 70-year-old Soviet leader Leonid Brezhnev on next year's priorities. After discussing the routine matters related to the motherland, Smirnov's tone suddenly changed and turned grave. According to a report written by Robert Windrum for NBC News, Smirnov told Brezhnev, quote, "The Americans are intensively working on a winged space vehicle. Such a vehicle is like an aircraft. It is capable through a side maneuver of changing its orbit in such a way that it would find itself at the right moment right over Moscow, possibly with dangerous cargo." Although the American shuttle program had not been designed to support weaponry, Smirnov and other high-ranking officers believed that the US was working on a space bomber capable of threatening Moscow with nuclear weapons. Smirnov's intel suggested that the US shuttle had a 30-ton payload to orbit capacity and a 15-ton payload return capacity. For him, that was a clear indication that their enemy was testing and placing laser weapons into orbit to destroy enemy missiles. Marshal Dmitry Ustinov, a veteran from World War II and member of the Presidium in charge of the USSR's defense, was convinced by Smirnov's words and urged the Soviet leader to take action. If the US was building a space bomber, Ustinov concluded, then so should the USSR. Even though the Russian officers greatly exaggerated the threat, they succeeded in alarming Brezhnev into securing the funds required to build an aircraft similar to their American counterparts. Once Smirnov finished his report, Soviet leader Brezhnev said, quote, "We are not country bumpkins here. Let us make an effort and find the money." Worried about the secret American superweapon, Brezhnev immediately ordered his closest officers to collect the colossal amount of money required to gain the upper hand against their American counterparts. Based on NBC's 1997 investigation, a Russian journalist would later write, quote, They began to use the shuttle to frighten Leonid Ilyich Brezhnev, and they explained to him that damn shuttle could zoom down on Moscow at any minute, bomb it to smithereens, and fly away. Brezhnev understood. Yes, of course. An alternative weapon is necessary. According to Windrum's NBC report, not all Soviet leaders had been convinced by the American space shuttle's threat. One of them was Marshal Georgy Grechko, the Minister of Defense, who was turned off by the large amount of money required to build a Soviet aircraft of similar characteristics. However, Brezhnev's fear was understandable. Like any other weapon created by either superpower, there had to be a counterpart to change the tide. That was the whole point of why the arms race took place, and why there was never a direct confrontation between both powers. The theory of mutual destruction made the US and the Soviet Union think twice before making a move. Intercontinental ballistic missiles were not a subject to mess around with. If the USSR built a shuttle of its own, the US would be forced to take a defensive stance. In February 1976, the project was authorized by the Communist Party's Central Committee and the Soviet Council of Ministers. The USSR would attempt to shift the balance of the Cold War. Colonel General Alexander Maximov, who ran military space and missile programs, was tasked with the shuttle's development. There was, however, one problem. Although the USSR's most intelligent men were part of the space program, the country still fell behind the US in terms of technology development. The Soviets were some decades behind the Americans, and instead of building their own spaceplane from the ground up, the Soviets decided to catch up with the help of the KGB and the VPK. Yuri Semenov, one of the developers of the Energia booster program that the new space shuttle would use, said, quote, "It was said at meetings on various levels that American shuttles, even on the first revolution, could perform a lateral maneuver and turn to be over Moscow, possibly with dangerous cargo. Parity is needed. We needed the same type of rocket space system." The Soviet Union had to build a space shuttle fast. There was no time for experiments. Consequently, the USSR decided to ditch a program created back in the 1960s to make a reusable spaceplane. This new effort was dubbed the Spiral Program. Russian engineers thought they could restore their old project to build a new spacecraft, but it was promptly rejected. Authorities at the VPK and the KGB came up with a new plan. By stealing information from the American space program, the USSR would save money and time. So the VPK got to work to gather the materials and the technology required to build a space shuttle. At first, Soviet spies would simply leave the Soviet embassy and purchase copies of public documents from the government printing office. Soviet intel was surprised to discover that the US had decided not to classify its program. All the info that went into the American Enterprise program in 1972 was open to the public. The US knew that the VPK was in the technology transfer business since the early 60s. Still, it did not know about the massive amounts of money the USSR spent on espionage to steal US info. Almost 500,000 rubles, the equivalent of roughly $140,000 at that time, was dedicated to gathering intel related to the US shuttle orbital control system. According to a study by the CIA, research centers such as Caltech, MIT, Brooklyn Poly, Princeton, Stanford, Kansas, Penn State, and others were also closely monitored by the KGB to gain info. Once the CIA and the NSA discovered what the Soviets were doing, it was too late to retaliate. The KGB had already hacked many computers to transfer thousands of documents from government agencies and universities. In his article, Windrum wrote, quote, "The massive effort directed at the U.S. Space Shuttle program was among the first cases of internet espionage, if not the first case. Soviet interest in NASA activities focused on everything. The USSR acquired everything needed to build their aircraft from materials and components for airframe designs and propulsion systems. The NSA later discovered that the Soviets used Vienna and Helsinki's research centers as covers to send the intel to Moscow. Under President Reagan's administration, the CIA concluded that most of the information stolen went directly to the Chamber of Commerce and Industry in Moscow. By the time the US launched the Space Shuttle Columbia in 1981, more than 3,500 documents related to the American space program were online. These included shuttle wind tunnel tests, booster rockets, the shuttle's computers, and its military applications. CIA and NSA officials told news outlets that the USSR's shuttle program saved billions of dollars and decades of research by using online spying. When interviewed by NBC News, Edward Aldridge, Secretary of the Air Force during the Reagan administration, said, quote, "They didn't have to put their orbiters through all the wind tunnel tests and computer simulations we did, because our test data was available to them." The Russian copycat space shuttle, Buran, only completed 2 orbits in 1988. During a space display at the Baikonur Cosmodrome in Kazakhstan, it suffered severe damage after the roof housing collapsed. The shuttle was never repaired. 1 year later, the Berlin Wall fell, and the USSR swiftly dissolved. Some parts of the copycat are currently displayed in various museums across Russia. The Buran looked almost the same as the US shuttle. However, technically, the Russian spacecraft was far more powerful and reliable thanks to the Energia program. While the US shuttle required 2 boosters to assist the main engines to get into space, the Buran was strapped to the Energia, a heavy lifting rocket that required an extra 4 external liquid-fueled boosters. Another feature that the Buran had and the US shuttle lacked were ejection seats. Unintentionally, the Buran copycat space shuttle laid the foundation for future American and Russian system compatibility. From 1995 on, US space shuttles started linking up to Russia's Mir space station with little modifications. On September 18, 1968, Western intelligence picked up a signal from Zond 5, a Soviet lunar mission. The messages were unusual. They emitted the voices of cosmonauts Valery Bukovsky, Vitaly Sevastyanov, and Pavel Popovich, speaking as if they were just about to land on the moon. Quote, "The flight is proceeding according to normal. We're approaching the surface." The CIA and NASA were horrified and didn't know whether Russia had just beat them to the moon or if it was all a hoax. Ultimately, it turned out to be a little of both. By 1968, over a decade had passed since the Soviets had stunned the world with the Sputnik launch, and only a few experts believed the Soviet Union had a slight chance of beating the United States to the moon. NASA had their new Saturn V rocket ready by the fall, and the Apollo program was only weeks away from launching their first crewed flight. Meanwhile, the Soviets, thanks to infighting and funding issues, still didn't possess a functioning launch vehicle that could carry a spacecraft to the moon with the heavy cargo needed to support human life safely. Besides, the Soviet space program suffered a degrading public image with an extensive list of delays, impediments, and tragedy, including cosmonaut Vladimir Komarov's ill-fated mission in which his spacecraft fell back into Earth. The Soviets didn't have anything to lose, so the Zond 5 mission was their last-ditch effort to beat America in a space milestone. If they couldn't send Yuri Gagarin to the moon before the Apollo men, they would at least be the first to successfully send a living being to the satellite. The launch was set for mid-September of that year. In the race to get humans to the moon, the Soviet Union funded two separate programs. The first one, the N-1, was the Russian counterpart to NASA's Saturn V rocket, whose ultimate mission was to land a single cosmonaut on the satellite. The second program was named Zond, the Russian word for probe, and included two independent series of robotic spacecraft machinery launched in the mid-1960s. Its objective was to send two cosmonauts on circumlunar missions without a moon landing. After several failed launch attempts, the Russians finally achieved partial success with Zond 4 in the early spring of 1968, testing the spacecraft system to lunar-like distances, but not around the moon itself. A few months after analyzing the technical problems Zond 4 encountered during a failed soft landing in Soviet territory, the Russians were ready to try again with Zond 5. The Soviet scientists then decided which animal or life forms would be best suited to travel to the moon. Due to their easy-to-secure shells, the experts chose two Russian tortoises for Zond 5, each with a pre-flight weight of 0.75 to 0.88 pounds. There were two other tortoises used as control specimens, and four more in a vivarium. In addition, the scientists also selected a diverse biological payload for the mission, including various legumes, fruits, root vegetables, fruit fly eggs, and single-celled strains of bacteria and wildflower species. The purpose of sending this diverse lightweight payload was to test a wide range of terrestrial lifeforms' effects when coming in contact with cosmic radiation. However, whatever the outcome of the tests, the results would not be analogous or equivalent to humans, as all of the chosen lifeforms had high radio resistance. Thus, the Russian Academy of Sciences put a dummy with radiation sensors on the pilot seat to achieve as similar an effect as possible at the time. On September 15, 1968, Zond 5 successfully launched from the Baikonur Cosmodrome in Kazakhstan. After a short time in a low Earth parking orbit, the device's upper stage ignited again to send off the spacecraft and its small living crew to the moon. 3 days later, Zond 5 flew around the moon, 1,200 miles above the satellite's far side, and was ready to begin the trip back to Earth. Then, on September 21st, the spacecraft re-entered the atmosphere, but could not complete a soft landing in Soviet land due to a guidance system error, and instead splashed down in the Indian Ocean. During the spacecraft's recovery, United States Navy vessels photographed the Zond 5 bobbing in the water as Soviet sailors tried to recover it. Finally, in early October, a Russian cargo transport flew back to Moscow with the spacecraft in tow. On September 19th, the Jodrell Discovery Center Observatory in the United Kingdom and the CIA intercepted a strange series of messages. The messages contained the voices of famed cosmonauts Valery Bukovsky, Vitaly Sevastyanov, and Pavel Popovich reading out telemetry data and critical computer readings while discussing a landing attempt. The interceptors were shocked, and they wondered if the Soviets had secretly beat NASA to the moon. According to Gemini and Apollo astronaut and longtime NASA employee Eugene Cernan, the strange remarks shocked everyone on the receiving end. But unbeknownst to the men working for the Central Intelligence Agency, the Soviet men were only messing around, trying to hoax the Westerners by faking a moon landing. According to cosmonaut Popovich, quote, "When we realized we would never make it to the moon, we decided to engage in a little bit of hooliganism. We asked our engineers to link the on-the-probe receiver to the transmitter with a jumper wire. Moon flight missions were then controlled from a command center in Yevpatoria in the Crimea. When the probe was on its path around the moon, I was at the center. So I took the mic and said the flight is proceeding according to normal. We're approaching the surface." The Westerners bit the bait, and for a moment they truly believed Russia had landed on the moon. Even Frank Borman, U.S. space advisor, received an angry phone call from President Richard Nixon, who asked, quote, "Why is Popovich reporting from the moon?" The Russians' playful ways caused real turmoil. About a month later, when Frank Borman visited the Soviet Union, he specifically requested to talk to Popovich at the airport. Then, as soon as he stepped out of his plane, Borman ran directly to the cosmonaut and yelled, quote, "Hey you, space hooligan." Despite the landing issues, Zond 5 was the first spacecraft to complete a successful circumlunar mission while safely returning to Earth with its biological payload intact. The operation also retrieved high-quality photographs of the planet, taken at a distance of 56,000 miles. The Soviets had proven that they were not giving up on the space race, at least not without a fight. Upon hearing the news, a British top astronomer and space expert confidently stated that the Zond 5 mission showed Russia was ahead in the space race. In addition to this announcement, the British Interplanetary Society stated its belief that the USSR would be ready to send their cosmonauts around the moon in a matter of months. However, by October, American sources began to claim that the mission had not been as successful as the Soviets advertised it, and that in reality, the Zond 5 mission had flown further away from the moon than initially intended. The group of sources also claimed that the angle at which the device re-entered the atmosphere was too steep for an actual human being to survive. By November, the official Soviet news agency officially declared that Russia had become the first country to carry living beings around the moon's orbit. The tortoises, identified as number 22 and number 37, were analyzed and dissected after a prolonged fasting period and had only lost a tenth of their total body weight during the mission. They also showed no loss of appetite. The scientists concluded that the changes in 22 and 37 were primarily caused by starvation and entirely unrelated to space travel. That same month, the Russians also announced that Zond was planned as a precursor to a crewed lunar spacecraft. The announcement came only a month before the scheduled Apollo 8 flight in order to show the Americans their capabilities. However, that mission never happened, and Apollo 8, the first crewed flight to the moon, ultimately beat the Russians. On July 20th, 1969, the United States became the first country to put a man and a flag on the moon. The Experimental Passenger Orbital Aircraft Program, also known as Spiral, was a Soviet secret project created to develop an orbital spaceplane and fighter spacecraft. Work on this multi-purpose spacecraft began in the early 1960s in response to the American shuttle program at the height of the Cold War. The objective was to build a vehicle that could fly in orbit at Mach speeds and function as a reconnaissance, bomber, and interceptor spacecraft. The Spiral MiG-105 crewed test vehicle resulted from years of research and testing, and the orbital spaceplane flew for the first time in 1976. However, achieving their desired Mach speeds would prove a more challenging feat than expected. The British, French, Soviets, and Americans greatly benefited from the thousands of German scientists and engineers abducted after World War II to help them push the boundaries of modern technology. This included weapons of mass destruction and aircraft designs that got humanity closer to reaching outer space one day. While the Americans struggled at first to keep up with the achievements of the Soviet Union, and especially the feats of cosmonaut Yuri Gagarin, the creation of NASA put the United States on a path of steady improvements. It was then that Chief Commander of the Soviet Air Force, K.A. Vershinin, envisioned a one-of-a-kind project. To stay ahead of their enemy, Vershinin presented a proposal to Vladimir Myasishchev, head of the Central Aerohydrodynamic Institute and other aerospace manufacturers, to develop orbital and aerospace vehicles. Vershinin wanted to build a vehicle that could be pitched against the American X-20 Dinosaur, or Dynamic Soarer. Developed by Boeing, it was rumored that the X-20 was meant to be the first U.S. Air Force multi-purpose spaceplane, and that it would be used for aerial reconnaissance, satellite maintenance, bombing, and space rescues. This program would ultimately run from 1957 to 1963 with average results. When the details were leaked, Vershinin was confident that the Soviet Union could develop the first spacecraft capable of orbital flights. After insisting for several years, Vershinin's idea finally materialized in 1965 when Gleb Luzino-Luzinski from Mikoyan's OKB-155 Design Bureau was assigned to oversee the development of this air orbital plane, or VOS, as it was abbreviated in Russian. Z.A. Yaffa, chief of the TSNII-30 Research Institute of the Soviet Air Force, would supervise the program, along with other military and space organizations. The program would be known as Spiral, and its main objective was to develop the Soviet orbital fighter and study the possibilities of waging war in space with horizontal takeoff and reusable landing spacecraft. The Soviet Air Force and the Russian aircraft corporation MiG, also known as Mikoyan, proposed that the orbital fighter be configured in 3 different versions. The first one was a reconnaissance version of the Spiral that would carry radar and a state-of-the-art camera with a 0.75 to 1 meter resolution to conduct spy plane missions straight from orbit. The second one was a bomber version that would be equipped with powerful orbit-to-surface missiles capable of striking targets on Earth. Finally, the third version was an interceptor that would be used for dogfighting and destroying enemy vehicles in space. Although Spiral gained a lot of attention from the Soviet high command, Mikoyan felt the pressure of unmanned satellites that were already in use. However, Spiral had two advantages: its expected cost-efficiency ratio and the flexibility of having a fast-response orbital fighter as a backup. Preliminary studies included developing 3 full-scale models that were part of the so-called Experimental Piloted Orbital Plane, or EPOS, sub-program. Each model was made explicitly for wind tunnel testing at subsonic, supersonic, and hypersonic speeds. The initial results indicated that the 6.8-ton vehicles could reach a 160-kilometer orbit with an inclination of 50 degrees after being launched on top of an R-7 rocket from the Soviet base of Baikonur. The supersonic and hypersonic configurations would later be equipped with rocket engines that would give them a thrust of 26 tons, and this would translate into speeds that ranged between Mach 6 to 8, or 8 times the speed of sound. The Spiral MiG-105 spacecraft had a unique design and quickly earned the Russian nickname Lapot, which translates to bashed shoe because of the peculiar shape of its nose. The Vertical Takeoff Horizontal Landing Vehicle, or VTHL, had a standard delta wing that featured innovative variable dihedral wings. During launch into space and re-entry into the atmosphere, the wings folded upward at 60 degrees. As the speed of Lapot decreased to subsonic, the cosmonaut would lower the wings to the conventional horizontal position to facilitate flight. An air intake for a single turbojet was mounted beneath the vertical stabilizer to allow the Spiral to perform a powerful landing or a go-around maneuver if it missed the landing approach. Lapot was designed to land on skids deployed from a set of doors on the sides of the fuselage, and the pilot had to climb into it through a hatch above the seat. The Spiral would be protected by a scale plate armor made up of niobium alloy and molybdenum disilicide steel plates that allowed for thermal expansion during re-entry to Earth. In the case of an emergency, the pilot compartment was designed to separate from the rest of the vehicle and parachute into the ground as if it were an escape capsule. Controls comprised rudder pedals, a standard control column, and separate controllers for the jet and rocket engines. An SANU, or Automatic Navigation and Control System, measured the aerodynamic controls. Propulsion consisted of a single Kolosov RD-3635K turbojet, and 500 liters of fuel were enough for 10 minutes of cruise at full thrust. The propulsion system included a liquid propellant engine with a 1,500 kilogram thrust, while 2 backup engines provided another 40 kilograms. Fully loaded, the Spiral weighed over 4,220 kilograms. It measured 10 meters with an approximate wingspan of 6.8 meters and a wing area of 24 meters. From 1965 to 1967, the wind tunnel models were intensively tested at the TSAGI Research Institute in Zhukovsky, near Moscow. A final design was eventually approved, and the institute proceeded with vehicles launched by expendable rockets to test it at speeds that ranged from Mach 3 to Mach 14. Besides Mikoyan, other design bureaus also participated in the project. They included the Lyuki Design Bureau to develop the engine, KB Korolyov Design Bureau for the 2-stage rocket accelerator, and other renowned Soviet agencies. However, the program had difficulties when it came to developing the hypersonic version of the Spiral, as there was no technology available at that time to achieve the desired Mach speeds. The Spiral program was then stopped in 1969 and did not resume until 1974, when Soviet spies informed the Kremlin of the American development of the space shuttle. The test vehicle finally made its first manned flight in 1976. Flown by pilot A.G. Festivitz, Lapot flew well at subsonic speeds. 8 more flight tests followed sporadically until 1978, when the government officially canceled the program and focused on the Energia Buran space shuttle, widely regarded as a copycat of NASA's own space shuttle. Although the Spiral never left the prototype board, the data gathered paved the way for other Soviet space projects before the Soviet Union crumbled in 1989. The surviving prototype of the Spiral spaceplane can be appreciated at the Central Air Force Museum in Menino, Moscow Oblast, Russia.